Good evening, everyone. And today I'll be presenting overview of electrical machine design. So this webinar will be in two parts. In the first part, I will try to give an overview of the subject of electrical machine, or primarily we will be discussing electric motors as electric machine. And then in the second part of the webinar, I will try to give an overview of electrical machine design, the design philosophy, different disciplines involved in it, for you to get an idea that what all things you need to learn to get into this field. So this is the objective of the presentation. So let's begin with the presentation. So first of all, in electrical machines, we are going to discuss primarily motors. I hope all of you know what motors are. So motor is a very common thing that we can see around us everywhere. So I would say actually, whenever there is a motion, there is a motor. So and it is very true, especially in present time. So if you see any kind of motion, there is a motor behind it. It can be a rotatory motion, and motors are not just confined to rotatory motion. If there is linear motion, then also they are supported by motors. So that is the thing. And in the present time, wherever motion is involved, so previously, say for example, it used to be due to engine or some hydraulic or pneumatic system. Everywhere now they are being replaced with motors. So if we talk about motors, motors are essentially very old technology. It is not a new technology. It is more than a century old technology, and they have been very well adopted into industry for various applications. Industries use the motors widely, and that's why the motors are also called workhorse of industry. And if you know particular different types of motor, then particularly induction motors are called a workhorse of industries. And if we talk about motors, motors are from the very small size to very big size. So you can see motors as small as candy, and to very big, say two-story building also you can find motors in industries. Just to give you an example, your mobile phone, when it vibrates, there is a motor inside the mobile phone which is making it vibrate. So you can imagine the size of the motor that is going into your mobile phone. So if we talk about the power levels of motor, so you might be knowing that we measure power in watts, electrical power. So output of the motor is also measured in watts. So we can have motors from few watts, say 4 watt, 3 watt, to several kilowatts. So industrial motors are, it's very general to find industrial motors of 200, 300 kilowatt. So that is the variety of motors you can find. And for different application, just to name some application in your home: ceiling fan, mixer, wherever you see a blower, all these are very common application of motors for domestic application. And for industries, definitely there are a lot. But one thing, if you see why are these motors so widely used, there has to be some very significant advantages of motors above others system which can produce motion. So why are only motors being preferred? So primary reason for these are motors over a century, they have evolved, they have matured, technology has matured a lot. So their construction is quite easy as compared to other movable system. And then their control is easy. This is a very important point. Motor control is easy. So you want to increase the torque or the speed, it's quite easy to do it, especially in the present time when your microprocessors are so strong, when your rest of the supporting technologies, say power electronics, they are so strong. It is really a easy job, and we can do it with very high accuracy. Second thing is scalability. Scalability mean, say you want to increase the power of the motor, then it's really easy. Again, this is primarily because the motor technology has evolved to a very greater extent. And another very important point is reliability and durability. So reliability and durability of motor as compared to other mechanical systems are quite high. So that is the reason they are so widely used. And the one very important point is motors can operate at a very efficient um, rate. So motors can particularly operate more than 90% efficiency. So that's also one of the reason why motors are preferred. So we have already discussed that there are a lot of medical, domestic and industrial application where motors are used. And just to name, so motors, you all of you might be knowing, you can have motors, different types of motors. Just to name some, they are DC motors, they are called out by these names: DC motors, AC motors, induction motors, say BLDC motors. You might have heard other things also, say servo motors or stepper motors. All are different motors. Some of them are same, they work on the same principle, some have different principle that we are not seeing in this webinar, but these are different types of motor. So here it's just a classification of motor I have presented just for you people to get an idea. So primarily we categorize motor based on type of excitation. So there are two types of excitation. One we call it as AC excitation, another we call it as DC excitation. So in the DC excitation you have a particular set of motor which we call them as DC motors, whereas if we come to AC excitation, there are multiple types of motor in AC excitation. So there is uh, a bucket which we call it synchronous motors, and then there's another bucket which we call as asynchronous motor. And asynchronous motor, there is a very common type of motors which all of us have definitely seen, which we call as induction motor. So all your domestic application, whatever you see, or most of the industrial application, all are induction motor. So induction motor is one which is widely used, and primarily for a reason that this is the only type of motor which is self-starting in nature, whereas all other types of motor, say in the AC category, are non-self-starting. The other motor that we have in AC categories are synchronous motor. There you can have brush motor, brushless motor, reluctance motor. They operate in different principle. We won't get into details of this in this webinar. So now already a lot of application, for a lot of application motor is being used, but the interest in motor technology has been ever growing. The primary reason for this is because people have found new applications for motor all along, and that is the reason new types of motor are being developed and constant research is going on, and there is a huge demand in the motor industry. So the new application that are coming up for motors are primarily agricultural equipment. So wherever there used to be IC engine driven equipments, all are being converted to motor driven. A lot of equipments are there in agriculture. Then one new majorly one new field which is coming up is e-mobility. So all of you must have heard about electric vehicles, which are getting a lot of attention across world for various reasons, say to reduce pollution, or just to provide an option to the fossil fuels. So for many reasons, but the thing is it is coming up in a big way. So there also you have different categories. Electric two-wheelers are there, electric cars are there, electric planes are there, electric ships are there, and each of this have their own requirement. So that is why they different types of motor are suitable for different application. Another major application is medical application. So a lot of progress has been done in medical field in last few decades, I would say 2 decades, and a lot of sophisticated equipments have come up, and motor has played a great role in doing that. Another thing is everything is getting automated, everything is getting operated by robots. So a lot of demand in the robotics, and essentially all this, wherever motion is involved in automation and robotics, it is done by motors. So that is the reason These are all the new application where people are looking at to use motors. And if we talk about recent trends, recent trend in a sense how the motor topologies have evolved over time. So if you have a background of this, then initially say 100 years back it used to be only DC, and then um AC was invented. At the time only induction motor was there, and all this were directly operated from power supply. And then as the time evolved, people started looking at motors like BLDC, which we call as brushless DC motor, and induction motor. So this motors became popular, and now in the recent time people are looking at other topologies which we call as SRM, or say switch reluctance motor, or SYRM, that is synchronous reluctance motor and induction motor. So now, so it's not like SRM, SYRM or BLDC motors were not there say 100 years back when only DC motor or induction motor were used, but it's primarily at that time the supporting technologies for this motor were not present, which actually uh, which actually limited their use. So if we talk about motor, say some topologies, say SRM motor or synchronous reluctance motor, their popularity has increased because of other technological advancement. So there has been a lot of advancement in power electronics devices. Now we get switches that can switch power at a very high level of voltage, very high level of current. The switches are available, which was not there say 100 years back. And also advancement in VLSI field. So we just don't get switches that can operate at higher level, but we get it in very compact size because of VLSI advancement. And then advancement in soft computation. So today we have very fast processing speed with our microprocessors, so that can decide very fast, and the controllability of motors have become very easy because of this. And one more important thing is material technology. Material has evolved to a very great extent over the period of time, especially the critical materials. If we talk about magnets, very high energy dense magnets have been uh, discovered, and they have really made this topologies very attractive. So these are the reason, like other topologies of motor are also catching up with the conventional DC induction, and in fact to some extent they have left behind DC and induction because they have many other advantages. So if we talk about electric motor industry as a whole, it's a huge industry across the world, because there are multiple applications for the motor, as we have already discussed. So these are just the number. I won't stress that much on the numbers. These are with some expectation by 2025 this industry will grow to this level. And it's not just across the world, even in India also the industry has been really growing. uh, and if we talk about why this industry is growing, so apart from all the uh, industrial application, as I explained, all the new applications have been coming up. So especially if we talk about electric vehicles, it is coming up. If we talk particularly about India, government is supporting a lot for electric vehicles, and you can just imagine the market that vehicle has in India, vehicle market, particularly the auto market. And then you can imagine if each and every vehicle has to be replaced by say electric vehicle, then what would be the size of electric motor market. Same is true for agricultural equipment. In India, agricultural sector is very huge, and there all the equipments, if they are to be converted to electric driven, then there is a huge market for motors. So if we talk about future in the coming years, primarily the focus particularly in motors will be whatever previous motors are there. So for motors there are energy standard defines, uh, say electric energy efficiency 1, energy efficiency 2, that kind of standards are there. And all the manufacturers have to keep upgrading their motors over the period of time in terms of efficiency. So energy efficiency of motor is a very huge field where a lot of efforts are being made, and they will keep on evolving. Second thing is new topology of motor to replace conventional ones. For advantages like there may be cost benefit, there may be efficiency benefit, or say the size of the motor is better as compared to the conventional one. So all the previous or the conventional motors are being replaced. Then high energy power density motor for application like e-planes. So if you have to put a motor on planes or even for a vehicle, there are very specific characteristics that are required, that the motor has to be very high energy density so that the weight of the motor is very less. So same is true for other types of vehicle also. So if we talk about major players in the field, then these are just some of the name. I have put it some of the name which you might be familiar with. I have just put their name. But then again, as we already discussed, motor is a very huge, like the variety is very huge. So depending on application, there are different players which work for different applications. So if you only talk about electric vehicle market, then there will be few other players who are mainly working in electric vehicle market. So similar way for medical application, there will be another player. But these are some of the names which provide motors for automation or industrial application in a big way, and a lot of them are present in India as well. So going into somewhat depth of the design philosophy of the motors. So if we talk about design, so by motor, I hope at least you must be having an idea that it's primarily two disciplines are involved in motors. One is the electrical and then mechanical. So motors are also called in general electromechanical devices. So there also you can have an idea that there is an electrical and mechanical disciplines involved. So whenever we talk about motor, you can very clearly divide it into two different types of designs. One is the electrical design and second is the mechanical design, but both have to be carried out in sync, otherwise you can't make a good motor. So if we talk about the design philosophy, first of all, as we discussed, motors are for multiple applications. So the very first requirement for motor designing is to understand your application very well. You have to understand the operating conditions, you have to understand the torque speed requirement. Is it a single speed operation or a application where the motor speed has to be varied? What are the efficiency levels required? So what information is there for the application, you have to gather it and understand in a very much detail. Then only you should begin your motor design. So assuming you have already gathered the all the requirement, all the information about your application and whatever constraint you have. So there might be constraint also. Say only the supply can give you only 10 ampere of current, or only 15 volt is available, or there can be a constraint on the size of the motor, that motor has to fit in a particular envelope. You can't have motor bigger than that. So those kind of constraint might also be there. You have to list down all those in the very beginning. Once you have that, then the very first step is to clear about the initial sizing of the motor, to get an idea, to mention that okay, this should be the diameter or this should be the length to achieve all the performance of the motor. And this is primarily done because there is a lot of literature available, a lot many books are there. You can refer to those books and use the basic sizing equations and work out the initial sizing of the motor. Then this becomes your starting point for further detailed design. Then the next step in the design is to do the detailed electromagnetic design. As you can see, this third step. So here you can use a lot of commercial. So as I was discussing, the third step is the electromagnetic design, the computational software, commercial software, they give you a very accurate result. Some of the examples of this traditional softwares are, you would have heard ANSYS Maxwell or MotorCAD or Altair Flux. Then there are softwares by Infolytica as well. There are multiple available. You can use them for the electromagnetic design. Once electromagnetic design is part of the electrical design that I was talking about, once this complete, then we move towards the mechanical design of motor. Now, mechanical design, one very important aspect of mechanical design is the thermal design. So thermal is very important for any motor. It defines how much uh, operating time the motor will be safe, uh, and it has to be carried out in the very initial stages of motor design itself. Otherwise it will be a very difficult task to manage the thermal of the motors. So just after the electromagnetic design, we generally go to the thermal design, and generally there is a lot of to and fro uh, between these two steps to come out with a stable design or an acceptable design. Once that is done, we move towards the other aspect of mechanical design, that is the shaft design or the casing design, selection of bearings and all other things, just to put this whole package into one casing.